Okay, I'll start recording here, and we stopped in three items today, and we'll take the three items. The first one is temperature, second one is density, and I kept the last one is the toughest one, the conversion, until the end, because that's most confusing, even for students, even at the graduate level, even at the master degree level, they're still confused. It's not difficult, but if you know how to do it, then it's easy. But it's at the beginning, it's very confusing. So kept the confusing part at the end. So let's look at the temperature. Let's look at the temperature here. The temperature, we have three systems, correct? And you can recall from the first time we talked about, and we said we have three systems, and those systems are the English system, mostly is commercial measuring system. It's not used for science that much. And then you have the metric, it's heavily used until now. And then you have the international system, which is coming slowly is covering. Maybe in 50 years, the metric system will never go away because it's based on the exponent. But most of the time, we'll be using a lot of SI system, international system will be used. So I have a temperature here, and I want to see all those things here. So our reference here, as I said, reference we are using. Yes, question? Okay. Our reference here is H2O. And we will take this one this way here. Look, here is our, correct? This is the metric one. And here is in between the English system, okay? And somewhere here, this is the SI system. So why I'm doing this? Because we are using the freezing point and the boiling point of H2O. So freezing point of H2O in the English system is 32 Fahrenheit. And in the English system, freezing point is 0 degrees Celsius. And the boiling point of H2O is 100, in the metric system, 100 centigrade Celsius. And this is 212 degrees Fahrenheit. And the circle, small circle on the top means degrees. And the freezing point in a system, international system, is 273.5 Kelvin and 373.15 capital K. So now we know the difference here. So we can, out of this one here, we can come with the very nice relationship between those. We'll say the difference between this and this is 180 degrees Fahrenheit. And between this and this, between boiling and freezing, 100 centigrade Celsius. And between this and this, 100 capital K, Kelvin. So now we have a very nice way to recognize that we have, correct? We have a relationship between the three systems, which is the relationship we have gotten here, 180 Fahrenheit equal to 100 centigrade Celsius equal to 100 Kelvin. This is the relationship between those three systems. Now, let's look at an example. We want to look at the example. So can I take this one out? So now we know the systems, correct? Yes. Oh, the B means boiling. Oh, so let me write it. Maybe I'm sorry. So here it is. Yeah, B means boiling point, and the F. Oh, sorry, no, not Fahrenheit. Freezing. F is freezing. F. Okay, guys. So I made the difference between all those. So all those systems, the difference is 180 Fahrenheit. The difference in SI, the international system, is 100 Kelvin. The difference in the metric system is 100 centigrade Celsius. So it means that 100 centigrade Celsius equal to 180 Kelvin, 180 degrees Fahrenheit, and 100 Kelvin. So this is very important relationship. Make sure that you put. Now somebody will tell you to memorize. Remember the old days, 9 over 5, 5 over 9. Do I need to memorize this? No. Let's do an example here, and I'll show you. You don't have to memorize this. You go by drawing this, the same thing. We'll draw them the same thing. So can I take this one out? Everybody have it? Yes. Is that the K? The K is the difference between 273.515. That's the freezing point at the international system. And the boiling is 373.15 Kelvin. Capital K, not small k is designated for kilo. Small k, you will see later on, for kilo. So can I take this one out? Everybody has it? You can take a picture out of it, and you will see it in the recording anyway. And by the way, you can use snipping tool to snip anything from video, from YouTube. Freeze the video, and then use snipping tool here, as I showed you before, and you can snip anything from any video you want. You can take a snapshot of any video you want. I mean, it's easy. There is another way. If you have a software, you can freeze, and then you can download a section of the video, but not everybody has the software. But the easiest way is to use snipping tool. Yes. What's that? Yes, that's by definition. The boiling point, the freezing point in the international system is 273.15 Kelvin, and the boiling point is 300. So the 100 difference, the 100 Kelvin difference, that's equivalent to 100 centigrade Celsius, equivalent to 180 Fahrenheit. So I'm taking this one out, and let's look at an example here, correct? The best is to look at an example. What is the body temperature? Now, I know that I have in the class people, they go for professional degrees. So what is the temperature in the metrics? So here it is. I will put this one here, guys. This is the Fahrenheit. We said we start 32 degrees Fahrenheit. This is 212 degrees Fahrenheit. That's the Fahrenheit here. This is centigrade Celsius, 0. This is 100. And this is somewhere here, 273.15 capital K, and 3. Oops. It is, guys. 373.15. So I have the body temperature. Okay, what's the body temperature? Say it's 98. I would say 98 degrees Fahrenheit. So body, I'm assuming if you are not sick, you are in good health, and you go and measure your temperature, it has to measure about 98 plus 98 degrees point 0. I'll put decimal here. Fahrenheit degrees. So this belongs to the Fahrenheit system, to the English system, correct? What is this one here in the centigrade Celsius? How much is it? Again, how much is it in Kelvin, capital K? So that's our task. We are doing it, correct? So in order to do this, I don't have to memorize. I don't have to memorize. Now, the metric comes 0. So which is the lowest system from all those systems is the metric. Start to 0. But this one here starts to 32. Higher, correct? So in order to get this first the centigrade Celsius, question mark, I have 98.50 Fahrenheit. Well, I am going now with this one here. Let's see, right? I'm going this one here from this to this, going up or down? I'll give you, no, why up? I am 98 Fahrenheit. I'm the Fahrenheit system. Going to metric, I have to go what? Down. So if I have to go down, I have to subtract this minus 32 Fahrenheit. That's the difference between the 0 and 32. The 0 metric is 32 Fahrenheit. So this one here will have, see here? And then I have to put the relationship between the two scales. The relationship between the scales is 180 Fahrenheit. Why I'm putting the Fahrenheit here? Because this unit will come Fahrenheit out. This 32 0 here. I put it 3 sig figs. So 32 Fahrenheit, this is Fahrenheit. Fahrenheit will cancel with Fahrenheit, 200 centigrade Celsius. So how much is it? How much is it? What's the body's temperature in centigrade Celsius? Who is going for nursing? Okay, so only one student, 2? 3? Okay, don't be shy. Dental hygiene? Okay, yeah, that's good. You have to know at least the temperature of the body, correct? At least. So 98 Fahrenheit, how much is it? So you can think. So just minus this from this, multiply by 100 over 180. How much is it? Don't let me down now, guys. Come on. What will be? Somebody has it? Well, okay. It is what today? It is Monday. You have your excuse. You have your excuse. You have your excuse. Okay, you have your excuse. Sorry about this. I forgot this Monday, so I have to remind myself too. So here it is. Let's put it here. So let's put 98. And the good thing about this, I told you about this calculator, free calculator, is you can copy and paste the answers. 98.0 minus, I don't like working with the absolute exact values, 98, correct? Always with the decimal, you have always uncertainty, because when you measure it with the thermostat under the tongue, the temperature, you can come after 1 hour, you might see what the temperature is a little bit off, correct? So, and not this exactly. So it's to have it in decimal much more accurate. So here it is. Oops, sorry, here it is. Go back and 98.0 minus 32. Oops, what's that here? Just take the whole thing. 98.0 minus 32. That's 66, correct? So, yeah, that's 66.0. 66.0 multiply by 100 divided by 180. So what's the temperature? Come on, who is working in the dental hygiene or nursing? Come on, guys, you will know blindly. I was always surprising they know my nursing when I go for my physical, they know that I'm a professor of chemistry, they know. So they give me the Fahrenheit, I give them the answer in centigrade Celsius. So anyway, so how much is it? Come on, guys, who's working in towards nursing? How much? How much? 30 what? 36 point what? No, how much is it? We have to have at least the coming out is here 66.00. Oops, sorry here. So here it is 66.0. Those are absolute value. They are not absolute value. They are not part of sig figs, correct? 66.0, and the answer has to be 3 sig figs. So it is 37 what? 36 point what? Okay, 6 repeated. Then let's put it then 7. Okay, guys, 7 degrees Celsius. So we say that's about 37 degrees. 37 degrees is equal 98 Fahrenheit. Okay, so that's, did I memorize 9 over 5, 5 over 9? No. From where is 9 over 5, 5 over 9? This is coming from the fact that 100 divided by 180, this is 0, 0, this divided by 2, this is 5, this is what? 9. This is the 5-9 ratio. But still they don't know what the 5 over 9 is. This is 100 scale, centigrade Celsius equal 180 degrees Fahrenheit scale. That's the scale. So don't memorize 5 over 9, 9 over 5. Look at it this way. Okay, guys? So, everybody agrees? Now we are going from this to Kelvin. Never go through Fahrenheit to Kelvin direct. You'll get an error. Always use the metric in the system here. Use the metric as your reference, as the middle person or middle point. You go from Fahrenheit to metric to Kelvin. You go from Kelvin to metric to Fahrenheit, correct? Now I'm going to what? I have Kelvin, so I have to have Kelvin. I'm going from 0 to what? Look, from 0 to what? So what should I do here? I have to add or subtract? I have to add or subtract? Add, correct? I'm going up. I'm not going down the scale. I'm going up to scale. I have to add. So the 36.7 centigrade Celsius, but I can't add it to Kelvin. That cannot be. So I have to convert it to 100 centigrade Celsius to 100 what? Kelvin. That's the scale relationship between those two. So centigrade Celsius would cancel out with centigrade Celsius, and then I have to add here 273.15. You get the idea? Here it is. So I went from here, all the way from down, all the way up. So 100 with 100, they cancel themselves out. Correct? 36.7 plus 273.15, how much is it? 3.09.5? 85, that's 9. 85, because I need how much is it? 3 significant figure. So I can put 36.7, that's 3. So I can put 310. Correct? 85, 310 Kelvin. And then decimal. 3 sig figs. Yes. Oh, that's 85. That's rounded here. This is rounded here, guys. It's rounded. It was 85. But I need 3 sig figs. So I rounded the 8 is as a 1 will be 310. And then I put the decimal in front of the 0 to get the 3 sig figs. Correct, guys? Makes sense? Now I'm taking this and seeing if you can follow me here. Everybody has it? Everybody has this? Now, did I tell you to memorize 5 over 9, 9 over 5? No. If you go up to the scale from metric to Kelvin, you have to add 273. If you add from metric to Fahrenheit, you have to add 32. If you go down from Kelvin to metric, you have to subtract by what? Minus 273.15. If you go from Fahrenheit way back to metric to 0, you have to minus 32. Make sense, guys? Okay, let's do this one here. By the way, this one here, this one here is not coming in the exam. Sometimes they ACS people they put it there. So let's put now. I want to get 300 3 sig figs, correct, Kelvin into centigrade Celsius into Fahrenheit centigrade Celsius degrees and Fahrenheit degrees. So let's do it together. I am going from now centigrade Celsius first. 310 Kelvin. Okay, guys. Now you tell me what to do. I'm going from the SI to the metric, correct? What should I do? From metric is start 273. I mean the SI. The metric is 0. So I'm going from up to down. What should I do? Subtract. Subtract by 273.15 K. I have to what? To subtract. Because there is no relationship with centigrade. Now, out of this one here, then I use the relationship 100 K equal 100 centigrade Celsius. Now that will give me the answer. What's the answer here, guys? So the 100 to 100 cancels out. Kelvin cancels out. And how much is it? 36.9 centigrade Celsius. Did we get this one before when we went the other way? Yes or no? We get the same value, correct? Now we are going from this to Fahrenheit. So Fahrenheit. I'm going from centigrade to the Fahrenheit. Should I subtract or add? I'm going up. I have to add. I get that correct. So 36.9 centigrade Celsius. I can add it to the Fahrenheit like it is. They can two different systems. So I have to equalize it with the system here, which is 100 centigrade Celsius, 180 Fahrenheit. Correct? This one here. Then I have to add our 32 plus 32.0 Fahrenheit. So centigrade to centigrade cancels out. So how much is it? How much is it, guys? How much? 98.4. 98.4. This is Fahrenheit, which came with all the rounding of 0.4 is less, so it's really 98 at the end. Did you see that? Did you see how to convert those temperatures? We did not do any memorization of 9/5, 5/9. Yes. That's metric value. I want to centigrade Celsius. So I went from metric all the way up, down to 0. From SI to metric, so I have to subtract. If I go then in the Fahrenheit, I went from 0 to higher up, 32. So I have to add up. So did we get the reverse correct? We get them correct. Did I memorize anything? No. Did you memorize anything? No. You don't have to memorize, correct? So that's the temperature. Very rare they put this one here because the problem is even with some calculators who don't have USB, so the students will not cheat. With those USB, they have embedded 3 temperatures different. So if I put centigrade Celsius, it will give me whatever is equal in Fahrenheit. So some calculators, even if they don't have USB, but they do have this program inside. So therefore, ACS is not putting this question inside because some students will have advantage over the others because they have this program embedded inside the calculator. So, but at least you know how to manage the system. If I have to go up from lower to higher, I have to add up. Lower system to higher system, I have to add up. If I go from higher to lower, I have to subtract. I'll never go from Fahrenheit direct to Kelvin from the edges to system. The metric is the middle person, the middle measuring tool in between those two systems. Okay, guys? So now the second topic, that's went very good. I hope so. Any question about the temperatures? Temperatures and their conversions. Any question? No questions? Okay, let's look at the second topic, which is the lab this week for other for my I think my Wednesdays lab will have it. Not the Mondays, Wednesdays. Density. So what is density? Somebody will tell me what is density? The density is a ratio. Is what? Ratio. Ratio between mass over volume. Then what we have here, we have some information about this ratio. Well, it turns out, first of all, we look at the units. So the units of the density, which we can call small d, this is m, and this is small v. So the units is, if I have liquids, the units is gram for the mass, ml for the volume. So you will see the mass does not change. The volume will change in the units. For solids, the units is gram per centimeter cube. For gases, I have gram per liter. This is first the units. And this is a ratio. So this ratio here is very sensitive for the temperature and the pressure, correct? But mostly it's for temperature. So we have this. Can I take the next step? Everybody has it? Yes. Here, centimeter cube, cubic centimeter. Here it is. Whoever will go for dental hygiene or nursing, gram per cc. cc. Here. The physician will tell the nurse, give that patient 3.5 cc. cc is cubic centimeter, which is 1 milliliter. 1 cubic, which is 1 cc, is equal 1 ml. We'll learn this one here in the lab. Anyway, so but at least that's cubic centimeter. Cubic centimeter is, the cube is always for the volume, square for the area. So that's the difference. Per liters, yeah. That's liter. That's this liter here. And this is milliliter. Okay, guys. So, any question? Let's go further. Now we know the units of the density. We know the dependence on this density here. Density always depend on density here. Depends on temperature and pressure. And mostly on temperature. Mostly on so if I give the density, I have to give the temperature. The pressure, the density is taken so always is 1 atmospheric pressure. So, but the density, for example, density of H2O at 25 degrees. So always you will see we have to give the temperature. We are measuring the temperature in. So it's about 1.00 gram per ml. That's for H2O. So H2O density at 25 degrees. Of course, if I change the temperature, the density will what? Change, correct? That's what I tell you. The dependence on the density depends always on the what? On the temperature mostly. The pressure not that such because we keep the pressure is constant at 1 atmospheric pressure. So this one here is pressure. is kept at 1 atm, 1 atmospheric pressure. So that's almost, we keep the ratio. It's not depending on really the pressure, it's on the temperature, because changing the temperature, the volume will change, and therefore the density value will change. Okay, so that's number 2. Number 3, yes. 1 atm, atm means atmospheric pressure. 1 atm means 1.00 atmospheric pressure. 1 atmospheric pressure. Okay, guys? So now, more than welcome. So next, we'll go and look at the physical property of the density. Is the density an intensive physical property of the matter, or is extensive? So, and we'll explain what we mean by intensive and what we mean by intensive. So, can I take this one out? Can I take this one out? Everybody has it? Everybody has it? Okay, good. So let me take it out. And I will say, now we are looking at the physical property of a matter, which is density. So density so here it is. Density is a physical property of a matter. So, and it is an intensive physical property. So now we are introduce ourselves to something called intensive. So what do we mean by intensive? When we talk about intensive, then we have something called extensive. Intensive versus extensive physical properties. Well, it turns out to be, let me just change the color. Here it is. Well, intensive, it means this physical property does not depend, intensive physical property does not depend, on the amount of the matter. Now, I'll give you an example here. 1 drop of H2O, the density of 1 drop of H2O equals the same density of a trillion gallons or trillion liters of H2O, okay, at 25 degrees. There's, whether you are measuring the density of 1 drop or trillion gallons or trillion liters, you end up the same thing, correct? So you'll end up the same density. So it does not depend on the amount, and that's what's said. So H2O density is the same for 1 drop or trillion liters at specific temperature as constant temperature. Temperature does not change as constant temperature. And we decided to have the pressure is 1 atmospheric pressure. So whether you measure the density of H2O or any matter itself, a piece of wood, a piece of iron, aluminum, all those matter, whatever matter you are using, if you use a small tiny piece of it or use a chunk of it, density will be remaining the same thing, does not change. That's what we call intensive. Intensive does not change with changing amount. However, the extensive, on the other hand, this one here, if you have this, I will. Okay, guys, can I take it out? I will give an example of the. Can I take it out? Everybody has it? Okay, you can take a snapshot of it. That's, I mean, use your phone, whatever. You can record if you want. So it's whatever you want to do it. Just no hesitation. So let me take it from here. The extensive, on the other hand, the extensive physical property here of a matter here will depend on the amount. Those are like volume, for example, mass. Those are physical property of the matter itself, but they are really changing because they are really depend on the amount itself. So it depends on the amount itself you are using. In any chemical reaction or something, it depends on the amount because you get different whatever yield out of this chemical reaction. So it's very, very sensitive for mass, volume, length. So all those extensive. But the intensive, regardless whatever you are using, is the same thing. Now, we don't have only the density. There are many other stuff is not changing. They are physical property. For example, this is extensive, correct? But if I say intensive here, does not change in the amount. So what's examples here? Intensive physical property here. Guess what? All these physical properties, boiling, correct? Boiling point, freezing point, correct? Sublimation point, deposition point, boiling, freezing, sublimation, density. Here we have the example of density, refractive index. If somebody will know what a refractive index is? Somebody will know? Refractive index. I'll give an example, just an example of refractive index. And each matter has its own refractive index. Each solution, it has its own. So if I put a light going through a triangle piece of glass, the white light you see is not really. It's a combination of 7 rainbow colors. Correct? Are you following me here? So that's the same thing. If I have a solution and let the light going through it, and you will see it will have, because the light will have to be absorbed, and it has different absorbance and different refractive. Refractive, when you hit something solid and come out, so part of it will be absorbed by the solution or by that object. So that's what we mean by refractive index. Are you following me here? Refractive index always, yes. Deposition point. When you hit a fish inside the lake or the river or the ponds or ocean, are you hitting with your whatever, with your line, whatever? Are you hitting the fish direct on it, or you just get out a little bit behind? Are you seeing the fish inside the pond or the lake or river? Why? What's happened? Because the light is going through two mediums, air and, okay. Whenever we have two mediums, then the light will start what? Refracted, okay, or deflected. And that's what's each solution or each compound will have its own solution, it has its own refractive index. So that's what it says. So those just an example of there are too many other stuff. So, and let's look now at the worksheets of the density. It's coming inside the final exam. Yes, that will come in the final exam. Density. So, can I take this one out? Take it out. Everybody has it. Okay. So now let's look at this. We have, and I'll show you all the time. If I have one formula, density is mass over volume. Of course, all our densities measure at room lab temperature, which is about 22 or 25. It's always 25 degrees. This is the main formula, correct? Can I make out of these two formulas, sub-formulas? That's the main one. Okay. Can I make out of this two sub-formulas? Okay. Let's look at those two sub-formulas. So I can determine the mass, which will be density multiplied by the volume, cross-multiply, correct? And the other sub-formula is I can say the volume is mass over the density. So now I have two sub-formulas from one main formula. Okay, guys? Let's do the worksheet and see. Okay, I will wait. Cool yourself down. Cool yourself down. Cool yourself down. Cool yourself down. I'm not wiping anything out until I'll let you know in advance. Okay? I'll let you know that I'm wiping. So, yeah. So don't panic. Just cool yourself down. So, I will ask. Okay? You can write and you can take snapshot. You can record if you want to. You can do whatever you want to do. So, for once, for twice, for what, thrice or third time? For thrice? No? Can I take it out? Okay, good. Excellent. So that's, let's look at the worksheet here. We'll look at the, together here, we'll look at the, let's look at the density. And as I said, density and significant figures in chapter 1, they will come with you in every final exam. And in our exam and quiz, they will come because this is very important. So let's look at the density. I think I do have density somewhere. Here I have a couple of those, three of them here. So you can see some of them with answers, some of them without answers. Let's see here. I'm not mentioning anything about graphic, the specific gravity. The specific gravity is a ratio between two. Maybe I have to mention this, but we don't cover it in the lab, so I'm not covering it in the lecture. And let me just tell you, this is maybe you don't know here. There is another thing here. I have the density as a ratio, correct? So let me come here and then I have the density as a ratio. We said the density as a ratio is mass over the volume. And our values most of the time at 25 degrees, unless it's indicated otherwise. So, okay. Now, if I have the density here, correct? The density of H2O at 25 degrees for H2O, correct? Or no, this is, yeah, that's correct. That's just, hold on. This one out. Right here. And the density at 25 degrees for any matter. And this one here, I'm sorry, not 25 degrees, that's 4 degrees. At 4.0 degrees Celsius. And this we call capital G. This one here, specific gravity. We are not covering this one here in the lab. In the past we did. So I was bringing this one here, but I'm not bringing this one in the quiz or the exam anymore. And the ICS exam is not. So this is a ratio between between the density of the matter at 25 degrees to the density of H2O at 4 degrees. 4 or 1 is the same thing. So this one here will be 1.00 gram. 25 or 4, that's the same thing, gram per mel. And this one here, whatever the matter is, the density of the matter at density of 25 degrees of any matter here, any matter. So if I have the ratio of those two, therefore I have something called specific gravity. Specific gravity does have no units because this one here, gram per mel, correct? And this is gram per mel, so those are canceling themselves out. So unitless, this one does not have any unit, unitless. And it's a ratio between two densities. Any density of a matter related to the density of H2O. Anytime I relate any density of any matter to the density of H2O 1.0 gram, I speak about specific gravity, correct? So we'll not worry about this. In the past, as I said, we did because we had the lab for it, but now they took it out of the lab. So therefore we are not worried about it. But at least you get the idea. That's how you have it here in the lecture. So if you find it one day, you know what specific gravity is. So can I take this one out? Okay, so let's go back and look at the density here. Maybe we'll be able to okay, guys. This is about specific gravity. We don't need the specific gravity, but okay, guys, here it is. The specific gravity. I don't want to go for specific gravity. That's all specific gravity. So, well, let's take another one. Let's take another one. Here it is, guys, and as you can see here, density gram per mel, and this is the density. This is whatever the example here, and here the other sub formulas. You can get the mass, you can get the volume. So the only thing we have to watch for unit cancellation. For what? Unit cancellation. Let's take, for example, this one here. What specific gravity? We don't need specific gravity. Let's see. Look at, guys, mercury has a density of, let me take this one here, snip it. It's my favorite snipping. So here it is. I'm snipping the whole thing here. And then edit, copy, and take it to, it is, paste it. And I can make it bigger here so everybody can see it. Bless you. So I can take it here, make the layout is. Okay, guys, so what is the volume of 20 grams of mercury in centimeter cube? You have mercury density is 13.6 gram per centimeter cube. What is the volume in centimeter cube? So I can fool you, I said in milliliters, correct? So let's put this one here. Let's verify this one here and say, okay, we'll have it in milliliters. Okay, so here it is. Mels. Milliliter, not centimeter cube. So it's given to you the density. Density is 13.6 gram. That's a solid, correct? Mercury is a solid. I mean, looks like liquid, but it's a liquid, but it's considered in gram per centimeter cube. It's a liquid. It's a metal. It's a liquid. So 13, not a really solid, but it's a metal. So liquid metal. So 13.6 gram per centimeter cube. And it has the mass of 20.00 gram. It's asked the volume. The volume we don't know. So we have the density is mass over the volume. So the volume is mass over the density, correct? So we are using this. So volume is, mass is 20.00 gram, and the density is 13.66 here gram per centimeter cube. So our answer, the gram would cancel out with the grams. So grams cancels out, the gram centimeter cube will be there. So we have 4 sig figs. We have to watch for the sig figs and the units. So all the density here, straightforward calculation. But the problem is, the trick is, you have to watch for sig figs and you have to watch for the significant figures, and you have to watch for the units. So this is 4 sig figs. This is 3 sig figs. So how much is the answer here? 3? No, not 3. 1.47. So 7 what? 7 something? Come on, guys. 7, there's none there? Okay. We need 3 sig figs anyway. So this is the answer here, correct? But I asked in milliliters. So your answer is 1.47 milliliter. The milliliter is equal centimeter, cubic centimeter. So, and the answer is in 3 sig figs. Okay, guys? Yes. No, that's divide, not subtract. Divide. That's the line here, divide. Yeah, divide. Okay, guys? So, you get the idea. Let's take another one, and then we'll go for the most difficult part. Get this. So, can I take it out? Everybody has it? Everybody has it? Okay, so let me take this one out. And take this one out too. So here it is. Take this one out too here. Okay, so let's take, we had the volume, we can get the mass. We are not going specific gravity, as I said. Okay, let's take this one here. We're looking for the mass, guys. So let's take this one here, snip this one here, and snip this one here, copy, and go to home, and then paste everything. And you can take this one out a little bit. Just hold on. I have to make the layout higher. I mean lower. 0.5, and now we have. So it is. Yeah, we did not take it very well, so we should be having. Okay, just repeating myself here. So let's take this one here out. Here it is, guys. So here it is. Okay, guys. So if you look at this, the active ingredients of a nice glass of white Zinfandel is ethanol. Ethanol has a density of 0.789 gram per centimeter cubic centimeter. We know that's liquid, it has to be milliliter, but this is just to fool us. Centimeter cube or cubic centimeter is milliliter, correct? 1 centimeter cube or cubic centimeter is equal to 1 milliliter. So what is the mass of the in grams of the 100 centimeter cube or cubic centimeter? Correct, guys? Okay, guys. So always when you tackle those type of problem, always look whatever is given and whatever is asked. So it's given for you here. The density is given to you of this ethanol, which is 0.789 gram per mil or gram per centimeter cube. We'll use centimeter cube because the volume is centimeter cube. The volume is 100 centimeter cube, sorry, 100. And you'll see all of those are what? Centimeter cube. All those 3 sig figs. So the mass, we know that the density is mass over the volume. So mass is density multiplied by the volume. So mass will be 0.789 gram per centimeter cube multiplied by 100, and there's a dot here, that's 3 sig figs, centimeter cube. So the centimeter cube, the centimeter cancels out, and the units in gram, the mass in gram will be, how much is it? 78.9 grams. Okay, guys? So everybody knows how to do it. So we did the mass with density. So the main thing is the density, always you have to watch in the density. So you have 2 things here. Sig figs issue here with the density and the units. You have to watch the units. You have to watch the units. Yes. Because that's the volume here, and this is the density is the mass over the volume. So the volume with the volume cancel. They both of them cancel themselves out. Okay, guys, everybody has this. Everybody has it. Okay, good. Thank you. And cool yourself down. So it is. So now we are talking about the most difficult part. Okay. Somebody is printing out this chart of the conversion. You need it for the quiz and the exam. But the final exam, you are on your own. That will be given to you, the units. So we'll start in English to English first. So we'll start what? English to English. That's the easy part. That's not difficult. English to English is not difficult. English system to English system. So English to English. So I'll give you just the mass here, just an example. And I give you the conversion here. 1 ton is how many pounds? Somebody will tell me. How many? 1,000? 2,000. Perfect. Where I can find this one, whenever you go to elevator, you look at the elevator and tell you the max capacity it can take. Will tell you this indirect there. 1,000, they give you them then in pounds. So 1 ton is 2,000 pounds. Correct? Now I want to see how many pounds if I have 3.5 tons. So how much in pounds? That's easy, correct? That's very easy. So I am looking for the pounds, and I'm given 3.50. I'm not doing anything except units cancellation. The key of this conversion, unit cancellation. So let me write key unit cancellation. Unit cancellation. So if the units are not cancelling, then I have somewhere some mistake. Somewhere I made the mistake. So then I put this one here. I like to have decimal. So pounds. So 10 with 10 cancels out. Then I have, how many sig figs I will have? My answer is this. No, this is 4. Okay. This one how much? 3. So my answer has to have 3 sig figs. So if I put this one here, how much is it? Somebody had calculated. How much is it? How much? Let me see here. 3.50 multiplied by 2,000. 7,000, correct? That's good. 7,000. Well, this is, I can put this one, but I need to make out the 7,000 three sig figs. How I do it? That's the question I like. That's really the question. So somebody will help? Any ideas? Remember scientific notation we talked about? This is a large number. I want to squeeze it. I have to go in. I want to squeeze to the left. Now, to the right, I have to expand it, correct? Make it bigger. But I want to squeeze it to what? To the left. The power of the exponent will be positive or negative? I want to hear it. I know it's Monday. I know it's still Monday. It will be what? Positive. So if I go to the left, power is positive. If I go to the right, power is negative. And it's up to me. I need three significant figures. Well, I like to move the, create a decimal here. I'll make it another color here so you can be changing the color, keep the students awake, not sleeping on me, start snoring a little bit, especially in the back here somewhere. So here it is, putting there 3. I created the decimal and I move it 3 digits. So this one here, I said 7, 0, 0, 0. I created the decimal here after 3. So 10 power what? I want how many? Oops. 3. So power, let me just take this one here, write it. Just hold on. I'll just write it again. So you should know how to do it. It's not really difficult, but I know 7,000, 10 power plus what? 3 pound, correct? Now I need to make out of this 3. I have here how many now? 4. The power exponent is not part of the 6. So I take one of 0 out. This is 7.00. The 10 plus 3 remains as is. Correct? Correct? Remain as is, pound. That's the answer. Yes. Okay, guys? So that's English to English math. That's straightforward. You can do the same thing with whatever is. I mean, you can do the length, yards to inches or to foot, whatever you can. That's straightforward. English to English, straightforward. The difficult part is now. Let's do it here. See if you can do it with the old high school method. I don't think so. You can make it with the old high school method with 2 zeros. So too many zeros. So here it is. I have to convert, and now is the second one. Convert 2.68 pico, correct? Whatever you like, mass, we took the mass, correct? Can we take the length? Meter, picometer, into terameter. Can you do that? Can you do that? Don't tell me the high school. The high school will be confused how many 0, 0, 0, zeros. So I'll show you here. First, 2 steps. We have time. Yeah, we do have plenty of time. 2 steps. First, you have to go through the basic units, and then go through basic units. Then the second one, after going through the basic units, you have to inverse the value of the exponents. So, those steps. So let's do it together here. Let's take one that you keep you awake, maybe the blue one. The blue one is good. So I have the picometer here. Oh, that's too big. Here it is, guys. The picometer, what's the picometer stand for? What's the P stand for? 10 minus 12 meter, correct? And the terameter 10 plus 12 meter. We have to know this is tera, this is pico. Okay, guys? Now I have to go through the steps here together. So let's do it here together. So we have Tm. We don't know how many tera meter that will be. Equal to 2.68 picometer, correct? Or I can do it here. I can do it here. Let me see. Let's take it here. Okay, guys. So it is. Be prepared for it, okay? So Tm. This one. So here it is. The Tm tera meter will be 2.68 picometer over 1. I have to go through the basic unit. 1 meter here, the basic unit is meter. 1 meter is picometer, correct? How much? This is 10 minus 12. So I put in front of it the opposite amount of it, which is 10 plus 12. Somebody will tell me why I'm doing this. Well, 12 plus 12, and then 12 minus power minus 12, you add them up, will come up to be what? Here it is, 12 minus 10 minus this, then plus 12 is 10 power 0, which is 1, which is equal to what? If I multiply this one here, those here together, I get what? I get my 1 here. Okay, guys? So I'm going to the meter and then picometer. Picometer, P is 10 minus 12. I put the opposite of the exponent, 10 plus 12. Then I will go to the next one is 1 meter is tera what? Tera meter, correct? The tera is 10 plus 12. I put 10 what? Minus 12 in front. Are you following me here? 10 minus 12. Why? It's the opposite of the exponent. The exponent is plus 12. So then what I'll do here, 10 over plus 12, I have to go up. The answer will be 2.68. Picometer cancels with the picometer, meter with the meter, meter with the meter here, meter with the meter. Then I have to take this one up, the 10 plus 12, 10 minus 12, multiplied by 10 minus 12 terabytes, terameter. That will be 2.68, 10 minus 24 terameter. Check, everybody's checking your head. Wanna come back on Wednesday to look at it in more details. So know how we did it. Everybody's following we have to do it. So we'll come Wednesday. We'll come Wednesday and look into it again. Correct? We'll go and come Wednesday to so.